Welcome again. Here is another problem, and that bridges the relation between simple harmonic motion (SHM) and uniform circular motion. And this is one of those important problems you would like to solve in your life, because let's read the statement of the equation, and it says a particle of mass m moves in the xy plane due to the force varying with velocity h. And how does it vary? You can say by yourself that x component of the force is directly proportional to the y component of the velocity, and the y component of the force is directly proportional to the x component of the velocity. Here is a positive constant, that's fine, and I and j are unit vectors of the x and y axis, and there is some initial condition of motion that reminds you that you need to use the differential equation, and some kind of integration is going on. You need to do some kind of integration. The presence of initial moment, initial condition, always reminds us. So at the initial moment, that is t equals 0, the particle was located at the point x equals y equals 0 and possessed the velocity v0 directed along the unit vector j. That means this velocity is along the y-axis. Find the law of motion xt, yt of the particle and also the equation of its trajectory. So there is nothing to do in such kinds of equation, rather getting started. And since force is given, so I would like to write this force as fx, that is the x component of force, x component of the force, the projection of force along the x-axis, and that is simply a dy by dt. That is the y component of the velocity, and y component of the force is written as minus a dx upon dt. That is the x component of the velocity. So these are the forces, at least x and y components of the forces. So we can simply write it here that this will be mass into acceleration, that is m acceleration, x component of the acceleration. I can always write it dvx by dt, because this is the x component of acceleration, as a dy by dt, and fy simply we can write here m dvy by dt, mass into acceleration, and that will be equal to minus a dx upon dt. But these kinds of equations are something else. Like I would like to write one more step first, and that is dvx by dt equals a by m dy by dt, and dvy by dt equal to minus a by m dx by dt. And there is an established method to solve this kind of differential equations. This is called a coupled differential equations, where one order higher differential equation derivative is related to one order lower derivative of other axis, and these two kinds of equations are called together called coupled differential equations. And to solve them, we simply need to differentiate them once more. So I'm going to differentiate them once again, so that this becomes d2 bx upon dt square equals a by m. This was basically dy by dt. This is d2y upon dt square. That is y component of acceleration, or you can write it as dvy by dt, as dy by dt is vy, so you can write it as well dvy by dt. And this equation you would like to write d2 vy by dt square equal to minus a by m, and this is vx, so we can write it here dvx by dt. And see, things are easy now, because this equation becomes d2 bx by dt square equals dvy by dt you can find from here this value. This is minus a by m, so multiply it here and write here a square minus a square by m square, and dx by dt you can write here simply vx. This dx by dt can be written here simply as vx. So this equation becomes now workable, and so d2 vy upon dt square can be written equal to minus a by m dvx by dt, and dvx by dt is here a by m vy, so we need to multiply it by a by m and vy, and you can see these two equations. This equation is something you can remember from your studies. I can do one more thing before going for any further. I would like to write a by m, a square by m square as omega square. मैंने मान लिया. I just assume that here a square by m square is equal to omega square. Omega is some new constant, nothing else. So that the left equation can be written as d2 bx upon dt square equals minus omega square vx. And then right hand side of the equation you can write d2 vy upon dt square equal to minus omega square vy. And you could have remembered from studies, this is the famous differential equation, not related to our solution, but perhaps you can solve this equation somewhere. d2x by dt square equals minus omega square x. This is second order first degree differential equation, and its solution is quite simple, because you need to take the values of x, like if you can differentiate it 2 times with respect to time, you will get the same thing, like sine theta cos theta. So that means the solution to this equation is simply like this: c1 cos omega t plus c2 sin omega t. c1 c2 are nothing but constant of integration, and if you can differentiate it 2 times you will get the same result. So this can be the solution of this equation, and this is a standard procedure. You don't need to worry to solve it back. You can guess an equation if you have the knowledge of mathematical functions. This is the solution of this equation, and of course we also have the solution of these two equations, and that you can write here vx equals c1 cos omega t plus c2 sin omega t, And in the simple manner you can write for Vy equals C3, just change the constants, nothing else. Cos omega t plus C4 sin omega t, and like this. So that here, but you need to worry something about that you have two unknowns in this equation. Vx equals C1 cos omega t plus C2 sin omega t, two unknowns, C1 and C2. But you have only one equation, and unless you are not some kind of very ambitious student, you can't find the solutions of the values of two unknowns from a single equation. So we need one more equation, and to get one more equation, I'm going to differentiate it simply, so that Vx can becomes dVx by dt, and this becomes minus C1 omega sin omega t, and plus C2 omega cos omega t. And these are my 1-2 equations, and I can get C1 and C2 simply by putting the initial conditions. As you can remember the problem, and you can go there and watch again the video, and you will find at t equals 0, Vx was 0, because velocity was entirely along the y-axis. So x component of the velocity was equal to 0. And what was the value of x component of the acceleration? dvx by dt. dvx by dt, it depends on y component of the velocity, dy upon dt. That means y component of velocity was provided. It was present at time t equals 0, and its value was equal to v naught. And this thing is omega. So at the initial moment, dvx by dt is omega v naught, and dvy by dt is 0. dvx by dt is omega v naught, so that at the initial moment Vx is equal to 0, and dvx by dt is equal to omega v naught. And also I know that at t equals 0, Vy was equal to v naught, and dvy by dt was 0, because it depends on dx by dt, x component of velocity, that was 0 at t equals 0. I don't need here, I can put only these two values to get the values of C1 and C2. And I'm going to put t equals 0, that means sin 0 is 0 and cos 0 is equal to 1. So C1 equal to Vx. Vx was 0 initially, that means C1 is equal to 0. I just put the initial condition in equation 1, and I got the value of C1. Now it's time to find out C2, and C2 can be found from this equation. And I'm going to put t equals 0, that means sin omega t becomes simply sin 0. This term is 0, and cos omega t becomes cos 0, that is equal to 1. So that C2 omega is equal to dvx by dt, and initial value of dvx by dt was omega v naught. That means C2 omega is equal to omega v naught, and this gives us C2 equal to v naught. So we have the equation. We can find Vx, Ax in terms of time, but I need to find Vx, and Vx is v naught sin omega t, because you can see here C1 is equal to 0 and C2 equal to v naught. So Vx is simply v naught sin omega t. This is one of my equations I needed to find out. Now I would like to find the value of Vy. Vy is here. Vy is here. I can remove something to write a new equation here, that is dby by dt, because you can remember two equations, two unknowns. So we are going to find out the second equation, and that is minus c3 omega sine omega t and c4 omega cos omega t. And initial conditions was t equals 0, Vy was equal to V0, and dVy by dt, that was equal to 0, because it was dependent on Vx, that was initially 0. So if we can t equals 0, this C3 stays alive and C4 gone, because sine 0 is 0. So C3 equal to Vy, C3 equals V0. So I got C3 equals V0. And what about dVy by dt was 0 at t equals 0, and this term becomes 0 because t equals 0. We are going to put t equals 0, that makes sine 0 is equal to 0, and c4 omega, this term is simply like c4 omega, and c4 omega is equal to 0, that means c4 is equal to 0. So what about Vy? Vy is c3 equals V0 and c4 equals 0, that means Vy becomes V0 cos omega t. So we got Vx, Vy. Now we can find x and y, because we had to find the law of motion, that was x in terms of time and y in terms of time, and also the equation of its trajectory needed to be found. So, and this is going to be a long question, but we will continue solving it. Vx, we can write dx by dt equal to V0 sine omega t. So that I can write one more step here, and I can write dx equal to V0 sine omega t dt. And we needed to integrate it. X starts from 0 and going to somewhere x, and t is 0 to t. So that left hand side of the equation becomes x equals V0 by omega minus cos omega t, 0 to 2. I can make it plus sign. I can write t to 0 here. Just change the limits so that minus sign can be consumed here, and so that we got here x equals V0 by omega. Putting the limits, we can get 1 minus cos omega t. So I got the value of x here, x from here. And I can also get the value of y in terms of time by putting dy by dt, that is dy equal to V0 cos omega t dt. And I'm going to integrate it again so that it becomes left hand side of it becomes y equals V0 by omega, and this is simply sine omega t, or sine omega t, limit of sine omega t from 0 to t, so that it becomes only simply as y equals V0 by omega sine omega t. So I got the equations, x in terms of time and y in terms of time. One final step is still needed to be found, and that is the equation of its trajectory. So I'm going to find, we are here with x in terms of time and y in terms of time, and we are going to eliminate t from both these equations, and we will get the equation of trajectory of the point. So I can find here cos omega t. Cos omega t is omega x by V0 1 minus omega x by v naught. Okay, and sine omega t is equal to omega y by v naught. Okay, and we know how to eliminate t now, because we know these things. Cos square theta plus sine square theta equal to 1. So I can write here 1 minus omega x by v naught square plus omega y by v naught square equal to 1. And if we can elaborate things, we can write here 1 plus omega square x square v naught square minus twice omega x by v naught plus omega square y square by v naught square equals 1. And this gives us the equation omega square by v naught square x square plus omega square by v naught square y square minus 2 omega by v naught x equal to 0. And if we divide both sides of equation by omega square upon v naught square, by this term, we are going to divide both sides of the equation so that we can get x square plus y square minus twice v naught by omega x equals 0. And you can see here, this is the equation of a circle. You can remember from your text, this is x square plus y square plus 2gx plus 2fy plus c is equal to 0. And radius of the circle will become, first center of that circle will become minus g minus f. And the radius of the circle, you can simply write under root g square plus f square minus c. You can see here f is missing, f is equal to 0, c is equal to 0. Only the value of g here, and g, the value of g is simply minus v naught by omega. Compare these two equations so that g will becomes minus v naught by omega. And so center of the circle, you are going to get minus g, that is v naught by omega 0, f is equal to 0, and radius is simply under root g square, that is v naught by omega. Radius of the circle is this. So you got a circular motion. Both particle are circulating. If you want to draw this circle, we can simply draw it. Its radius is v naught by omega and its center is v naught by omega 0. So this will be a circle like this. And its radius being v naught by omega. And this distance is also v naught by omega. So it is touching the y-axis. And if you can see its equations, its x and y coordinates of the equations, you can see here, you can see from them, both are varying sinusoidally. That means our object moving with the fixed speed v naught, because fixed speed v naught, you can already say here, its Vx is equal to V naught sin omega t and Vy equals V naught cos omega t. So speed of the object is always V naught. So it's a uniform circular motion. And its x component, in a uniform circular motion, x component of the object is varying sinusoidally. Sine and cos are both sinusoidal functions, because you know sine, the basic three trigonometrical functions are sine, tangent and secant, and their co-function are cosine, cotangent and cosecant. Sine and cos are convertible into each other, so sine and cos both are sinusoidal function. So its x and y coordinates are varying sinusoidally, and sinusoidal, if the position of an object varies sinusoidally, then the motion is called sinusoidal motion, or in physics textbooks it is called simple harmonic motion. The term simple harmonic motion refers to the sinusoidal motion. And we all know about the immortality of sine and cosine functions. If position varies with time as sinusoidal, velocity, acceleration, and its derivative, and that's derivative, and that's derivative, and that go on, will never go die, will die, and they all be varying sinusoidally. So, in simple harmonic motion, simply position of the object varies with time sinusoidally, and velocity and acceleration are bound to vary sinusoidally. And basically, their plane motion is always a circular motion, uniform circular motion in general. So this is the relation between what is called the simple harmonic motion and circular motion. Here omega is the angular velocity of the circular motion. You call this in simple harmonic motion is simply by angular frequency, but this is nothing but this is the angular velocity of the corresponding uniform circular motion, and this thing is usually called phase. This is nothing but its velocity vector or position vector in particular makes an angle with initial radius vector. I will explain later. I'm not going to explain each and everything here. So this is the relation between, and what is the differential equation of this simple harmonic motion? So if these two are simple harmonic motion or sinusoidal motion, then their mother equation from which they are born, Newtonian equation, that contains force and mass and force and acceleration, is like this. It is either like this or like do you get I haven't mentioned them all, so we will mention them sometimes else. This video is going to longer if I try to do so right at this moment. So thank you very much for the time being.